So this next lesson is on piecewise defined functions. A piecewise defined function is a function, where's that highlighter? Is a function which is defined by multiple subfunctions, where each of the subfunction applies to only a certain interval. So in normal person talk, that means a piecewise function has more than one function that we're talking about, and it basically takes the domain and splits it into more than one interval. So for example, half of our graph is only where x is greater than 2, and half of our graph is where x is less than or equal to 2. So something that's kind of helpful is to go ahead and take like a highlighter on your graph and say, okay, at x equals 2, which is right here, one graph is going to be on this side. That's going to be on x is greater than 2. And one graph is going to be on this side. And so that's just kind of the thought. So the way that you can do this is, for my x plus 1 function, I'm only going to plug in numbers that are greater than 2. So like 3, 4, 5, and 6. For my negative 2x plus 5 function, I'm going to plug in numbers less than or equal to 2. So like 2, 1, 0, negative 1. So let's see what happens. When I plug in 3, 4, 5, and 6 to this function, I'm going to get 4, 5, 6, and 7. So I'm going to plot those. So 3, 4, 3, 4, 4, 5, 5, 6, and 6, 7. Okay, so then, but at 2, let's see what happens at 2. I would get 3. Because this is greater than 2, this is going to be an open dot. Because I don't actually want to include 2, but I want to include everything close to 2. So right here is going to be an open dot, and then this is going to go to the right forever. Okay? Now, because this is at 2, this is included, this is going to be a closed dot there. So let's see. If I plug in 2 to this, I get 1. If I plug in 1 to this, I get 3. If I plug in 0 to this, I get 5. And if I plug in negative 1 to that, I get 7. So let's see. 2, 1 is going to be a closed dot. 1, 3, 0, 5, and negative 1, 7. So you can see this is another line, but this is going to go to the left forever. So all we're kind of doing is breaking up our domain into two different parts on this one, and graphing two separate functions, but cutting them off at a place. So let's try another one. So this one's going to be a 3-part. So let's see, x is less than negative 4. So you're going to see at negative 4, there's going to be a cutoff. Between negative 4 and 5, there's going to be a cutoff. So you can see that there's going to be kind of 3 parts. Right? So there's kind of 3 separate equations we're dealing with. Okay, so let's do a 2 plus x. Let's do a negative x. And let's do an x. Okay, so 2 plus x. X is less than negative 4. So let's start with negative 4, but remind ourselves we're going to have an open dot. And other numbers that are less than negative 4. And we're going to add 2 to them. Okay, I'm going to go over to my graph and I'm going to plot those. So negative 4, negative 2 is going to be an open dot. Negative 5, negative 3. Negative 6, negative 4. And you're going to see it's going to go this way forever. But again, we don't actually want it to be at negative 4. Alright, so for negative x, I can plug in numbers between negative 4 and 5. And I can actually equal them. So at negative 4 and at 5, I'm going to have closed dots. And let's try like a couple numbers in between there. And I'm just taking the opposite of x. So this is going to be positive 4. I'm going to go over here. I'm going to do it in a different color. Negative 4, 4. I'm going to have a closed dot there. 0, 0. 2, negative 2. And 5, negative 5. And again, I'm going to have a closed dot because this had equal to's there. Okay? And then our last example is going to be x for x is greater than 5. So I'm going to start at 5. But again, this is going to be an open circle because it's greater than 5. And the function says just use x. So 5, 5, 1, 2, 3, 4, 5. I'm going to have an open circle there. And then 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. This is going to go up in that way forever. So you can see that piecewise defined functions, I'm going to erase all this gobbledygook so you can really see what it looks like, are functions that have 3 separate parts, that have 3 separate domains. All we're doing is being very careful about where we plug what into. So let's try another one. All right, this is another 3-parter. All right, so x is less than negative 2, between negative 2 and 3. All right, and so all I'm going to do is I'm going to take my 3 functions, and let's see what we can plug in. So for 4, I can plug in less than negative 2. Remember, there's going to be an open circle at negative 2. And this is saying all my y values are going to be 4. So negative 2, 4, it's going to be an open circle, and then all of my y values here are going to be 4. So that's just a horizontal line. Next color, I can plug in negative 2 until 3. It's going to be a closed circle at negative 2, but an open circle at 3. And then let's just plug in a middle point. And so all we're going to do is we're going to square our x. So negative 2, 4. So notice now we're supposed to fill this in. That's okay. It's okay that it's filled in now. 0, 0. And this is going to be a parabola. 3, 9. So it's going to look something like this. Uh-oh, and 3, 9 should be open. An open circle. And if you don't have different colors, that's okay. This would just be a closed dot right there. Okay, negative x plus 12. I can plug in 3 until 8. It's going to be a closed circle at 3 and an open circle at 8. And maybe I might just plug in 5. So I'm going to take negative 3 plus 12, negative 5 plus 12, negative 8 plus 12. So 3, 9, once again, that happens to be that same point, so we just fill it in, and that's okay. 5, 7, 3, 4, 5, 3, 6, 7, and 8, 4. And that's going to be an open circle right there. And it ends right there. And that is our final piecewise. Okay, the last one we're going to talk about is the absolute value function. If you guys remember from Algebra 1, the absolute value of x is basically, it's going to look like this. If I just plug in some x and y values, let's say I plug in negative 3, negative 2, negative 1, 0, 1, 2, the absolute value just makes these numbers positive. And it ends up looking something like this, a v, right? How would you define that as piecewise? Look, there's one part here that's a line, and then there is one part here that's a line. So basically, how would we write this as 2 separate lines? Well, we would do this big squiggle. Well, this line has a slope of 1 and a y-intercept of 0. And this line has a slope of negative 1 and a y-intercept of 0. And then we think, hey, what are their domains? Well, this part goes with this guy. This part goes with this guy. So what are the domains of each of those? Well, this one, let's say this is x is greater than or equal to 0. And this is x is less than 0. And you could do either order as long as one of them was included the 0 and one didn't. So that is piecewise functions.